You have to solve it by yourself. A minute. Okay. Do you know that how memory is allocated for a C program? If we run any program, we know that program will be loaded in memory and then it will execute. So if you want to run a program, the first task is it will be loaded in system memory. That means main memory or RAM, and then it will be started execution. Okay, so how much memory is allocated for that process? I will not say program at this moment. When the program is in execution, then it's known as process. I think you have clear idea about it. Like I'm writing a program. The program is test.c. So this program is kept in my file system. So it is not loaded in main memory. Now after writing the program, it's nothing but a file. It's .c file. So once we are compiling it, a.out file will be generated. This a.out file is again a program. So when it will become a process, it will become a process when it will start execution. Okay, so if we write something like a.out ./a.out and press enter, then it will start execution. Okay, so at that time it will become a process. So still the program executes, memory will be allocated for this process. So different types of memory is being allocated for this process, like heap memory, stack, BSS. So many things are related. Okay, so many types of different types of memory will be allocated. Now in our program, what type of variables we are using, whether it's local variable, is global variable, or it's static variable, based on that this memory is being allocated for this process. Okay, so do you have any idea that how this memory is being allocated? Hello?
No, sir. No, sir.
No. Okay, then let us start with one program. I think we have written some program previously. Let us oh, it's taking a long time. Okay, I have to increase this font size. Is it visible now?
Yes, sir.
Yes.
Yes, sir.
Yes.
Okay, I forgot in which directory you have written. It's in sample codes. Okay, going to that, and okay, we have discussed it. Okay, now let us create a new file. Say it's a memory. Say it's memory test.c. Okay, so we are going to write a program. It's a very simple program, so just hello world. Okay, so I will write this program. Are you familiar with VI editor?
Little bit, sir.
Can you copy multiple lines, delete multiple lines?
Yes, sir.
Okay. Try to be familiar with VI editor because in server
Sir,
side, if you
is
are,
VI and Vim both are same?
yeah, VI and VI modified. Which one
Okay.
is same? Okay. So let me just write a program. It's a simple program, and I'm going to print hello world. What happened? Yeah, I'm saving this program. Okay. Uh, I will remove some files which we have created earlier, like uh, test dot intermediate file test dot I, remove test dot o and test dot s. Okay, so we have only these files. We have created memory test.c. Okay, now I'm going to compile this program, memory test.c. Say I will create memory test. Okay, so after compilation, this is the file which is being generated. So memory test is executable file. Now if I want to test that how much memory is allocated, okay, so how, what are the different types of memory which are allocated here? So basically there are different types of memory. One is text segment, which is nothing but the code. It's also known as code segment. Another type of memory is data segment. Okay, so in your program, whatever data you are using, okay, some of this data, not everything, like we have static variables, local variables, global variables, and we may have different types of variables, but some of them will be stored in data segment. Initialized data segment is there, sorry, uninitialized data segment. Okay, we will discuss that what type of variables will be stored in uninitialized data segment. And we know that for every process there will be a stack memory allocation and heap memory allocation. We are familiar with this stack memory allocation because we know that in case of function call, the state of a function needs to be stored in stack. So from main function, if we call another function, then the state of main function is being stored in stack. Then program control goes to the called function. It will execute the called function. After that, it will return to caller. So in that way, in case of recursive call, the state of the caller function needs to be stored in stack. So stack memory will be allocated for it. And what is the purpose of heap?
Dynamically allotted one.
Yeah, so dynamically if we want to allocate this memory, then it will be allocated from heap. So for every process, heap memory will be allocated. Okay, it will not be an infinite. You can't allocate few gigabytes of memory dynamically. So in that case, obviously you can allocate it, but you have to apply some different approach, because we know that there is a concept of segment. When we are running a program in our system, there is a concept of segment. So block wise memory will be allocated. So if you need multiple block, then you have to manage it properly. Okay, so don't feel, so first of all I want to mention here, you have to understand the internals of a program. Don't think in the perspective of Python programming. Okay, how actually this memory is being allocated, you have to understand it in detail. You can write program in Python. The problem is until you manage the proper data structure, and variables, in your program will not be an efficient one. Nowadays, in 5 years, in next 5 years, it may happen that after 5 years, no one will learn C programming language, no one will understand the assembly level code. Obviously, the day is changing in that way. But still yet, like after 10 years or 20 years, still there will be some developer who will work in this area, and they will be the highest paid employees. We are making some abstraction. So when new languages are coming, so when we are talking about drag and drop related program, most of the things, the functionalities, data structures are already implemented. You can just call it. Okay, you can just call that function or method, okay, and your program will run properly. But there will be some developers who will develop the things in code level. Okay, so otherwise on different types of architecture, the things will not work properly. Like, just I can say you that in case of Java programming language, most of you are not familiar with Java, but in case of Java programming language, what happens that if we write a program, it can be executed in different types of platform. So it will be converted to bytecode. Okay, so .java file will be converted to bytecode. Now bytecode needs to be executed on a system. So we can execute the same bytecode on Linux, same bytecode on Windows environment. Okay, but how this bytecode will run? So there is a JDK. So either you may install JDK, or if in your system, if you have only runtime library, okay, JRE environment, then the program will run. But this JRE, if you don't understand how the things will be managed on this operating system, then it will be difficult to develop the code. Okay, so you have to understand how internally the things are being managed. Okay, that is the main objective. So if you can understand that how internally the things are being managed, then it will be easier to develop the code. Okay, so try to understand. You are not technician, that some people will come to you and they will ask that I have this problem, give me a software solution. So don't become a technician. Instead of that, try to be an engineer. Okay, so here I will show you that how the things are working. Okay, so what we can do here, I am returning to, okay, it has been locked. Just a minute. Obviously abstraction is needed, but in case of software development, everything cannot be developed in C, obviously, but because the time is limited, so we have to choose some platforms or languages where the things are working properly. Okay, so we are not going to develop an web application using C, but it can be developed, and the background of most of the system is developed in C. You know that in Linux environment, most of the code is written in C. Okay, but try to understand the internals so that it will help you to develop any application in efficient way. Okay, so we have written this program, memory test. Okay, now to understand the memory allocation of this one, we have to use this command size. Okay, so have you not ever used it? Hello?
No, sir.
Okay, so these are the different types of memory which are being allocated. So we have text segment, data segment, BSS, DEC, and hex. Okay, now just I want to show you that if I change this, I'm going to change this code and I want to declare a variable. I will declare a local variable first, int x. Say there is another variable, instead of int, say it's character variable y. Okay, and I want to compile this and test it. So I will compile this code and test it. Okay, I will find any change. Text is 13, 16, 1316, 548, 548. BSS is 4, 4. This is this, and hex is this. Is there any change? No. So basically, memory, when memory is being allocated, whether we have that much of data in our program, no. So when this program will work with lots of variables, lots of strings, lots of static variables, local variables or global variables, then based on that, these values will change. So memory allocation will change at that time. But for any process, at least few, for every segment, few memory will be allocated. When we require some memory which is more than this data segment, then the data segment size will increase. Okay, so this is the way how this memory is being allocated for a process.
Sir, my internet connection was a bit slow. Can you repeat what are these BSS and DEC?
Okay, I can share you this link. It will help you. I have not completed the note, so I'll complete it later. But in the meanwhile, I can share you this link in chat. Okay, but it's not complete. I will complete it by today. I have just started writing it, but it's not complete yet. Okay, so basically, in case of when you are running a process, then for that process, some memory will be allocated. In next semester, you will learn operating system. Okay, in operating system, what you will learn that when a process is being created, okay, so still we have a program, it will not be treated as process. So when we are going to run a program, then it becomes a process. We can analyze the memory requirement of a process based on the program. So once we have written this program, memory test, then for this memory test program, how much memory is required, that can be calculated from here. Okay, so we can analyze the memory requirement of any program. You know that in case of LL, okay, we have executed LL command earlier. So this memory test, here you can see that it is showing the size. Okay, what does it mean? This is the memory or size of the file. Okay, this is the size of the file when the file is stored in secondary storage. Now when this program will be executed, like if I want to execute this program, memory test, Then at that time it has been completed, it has been completed its execution. So if it has some input output, so it will wait. So during that time when the program is in execution, at that time how much memory is required, so that can be calculated from here. So if you want to analyze the memory requirement for this program, memory test, which we have written for this program, how much memory is required and what type of memory is required, that will be shown here. So for every process, this memory will be required. So it is managed using process control block. The things will be discussed in operating system class in detail. So when a process is being loaded in system, for every process there will be a process control block. That process control block keeps this information. Okay, so here what are the different types of memory which we require? As you can see, this is text segment, data segment. Generally instead of text we use the term code segment for this one. Then we have data segment, then we have BSS, DEC and hex. These are the 5 types of memory which are being allocated for this process. So what is text segment? So as I have just written enlisted it here, so text segment, it's basically the memory which is required for the programming logic. Okay, so you have written some programming logic within that program. So whatever code you have written, that code needs to be loaded in system memory. Okay, so in memory, when this logic is being loaded, it will be kept in different segment. For every types of data, or we have to keep different types of memory. Like in your home, do you keep book on your dining table or your plates and glasses in your reading desk? So the things, we can keep it. Is there any problem? No, we can keep it, but the problem is we arrange it properly because it gives us different types of benefit. Okay, so when we are working with some variables, like we are going to allocate some memory at runtime dynamically. So if we use malloc, calloc, this type of functions, if we want to change this allocation, we can call realloc function. So if we want to work with this, then what we have to do? Then a different segment is being allocated for it. So we have a different memory region where these things will be loaded. Okay, so we'll keep this code segment and data segment separately. Now we have different types of data. So different types of data will be arranged in different memory location. Okay, so text segment or code segment is basically the section of program in your main memory where the programming logic is kept. Okay, then we have initialized data segment. Okay, so this initialized data segment is basically it's don't know the virtual memory, so it's basically virtual address space of a program. Okay, so here what type of data will be stored here? If you have some global variable, if you have some static variable, okay, and which are initialized. So if you have initialized those global variables and static variables, so you know that in the global variables will be declared outside of any function. If we have some static variable, then the state of the static variable needs to be stored even if it is declared within a function and the function has been completed its execution and next time we are calling the same function, but still the static variable, the state of the static variable will be saved. Okay, so you can access the previous value of the static variable. So if you have this type of initialized variables like global or static variable, then the things will be stored in this memory area, which is initialized data segment. In when we have executed the command, then it is going under data. That's why it's also known as, though we are saying that it's initialized data segment and uninitialized data segment, but this initialized data segment is basically also known as data segment. Okay, now, and the third point is uninitialized data segment. So what is uninitialized data segment? So uninitialized data segment is basically, it would be very helpful if you understand assembly level programming language. Okay, so this uninitialized data segment is just for understanding at this moment. Think that if we have some static or global variables which are initialized, they will be kept under initialized data segment. If this the variables are just declared but not initialized, then it will be under uninitialized data segment. Okay, now if we talk about the local variables, where it will be stored. Local variables means the variables which are declared within a function and its scope is within the function only. It's not static variable. So where it will be stored?
Stack.
It will be stored in stack. That's why we say that when a function is being called from any other function, it can be main function or any other caller function, then state of the caller function needs to be stored in stack. So this state contains the local variables. So local variables means the current values of the local variables will be stored here. So for any local variable, whatever you have declared within a program, the things will be allocated in stack. Okay, I've just discussed with few lines. You can go through it later on. So you are already familiar, as you are already familiar with data structure. So you know that how stack is working. So it's obviously last in first out process. So in that way it is being managed. Now another important thing is dynamic memory allocation. At runtime, if we want to allocate some memory, okay, so this memory is being allocated from heap. Basically with a program, so when it is running, so when it becomes a process, a significant amount of memory is allocated for heap. So this heap segment, uh, for heap segment, a significant volume of memory will be allocated. So if we call this type of function like malloc, calloc, realloc, free, then we are working with this heap memory. Okay, so dynamically the things are being managed. So this is the very basic thing, so I wanted to share with you. Okay, if you have any doubt, then we can discuss. Just pardon for a minute. I have to receive a call. Just 2 minutes. Okay. Hello.
Yes, sir.
Yes, sir.
Yeah. What was the question?
Sir, I have two doubts. First one is like the BSS part, and second one is like why the global variable is in the initialized data segment and not in stack.
No. Um, if we have global variables, uh, let us think in that way. That what is the purpose of stack? The operations are last in, first out. Okay.
Yes, sir.
So the item, the elements. Sorry. The elements which are being added at the last time, the elements will be removed from there. So last in, first out, this operation is being performed. Now, if you keep this global variable within stack, what will happen? Say I have a recursive function call. Okay. Now, from main function, we are calling the factorial function. Say this is the simplest example. So from main function, we are calling factorial function. Now, when the state of main function will be stored in stack, do you want to keep this global variable with it? Or if you keep it before storing the main function in stack, if you keep the global variables in stack when you are from factorial function, if you want to access it, how you can access it? You can't access any element from a stack until it is on top position. So how will you access this global variable? If you want to access the global variable, then you have to pop all the elements.
Yes, sir.
Then we don't have the benefit of stack. At runtime, we can't remove some elements, then pick an element and again add those elements back to the stack. It's
Right.
not possible. So that's why global variables, static variables, these things should not be allocated in stack. Okay.
Yes, sir. And sir, suppose the static variable. So suppose the static variable I initiated with 0 or I haven't initiated itself. So will that be considered as BSS?
If you have initialized it, then it will be stored in initialized data segment. If it's not initialized, then it will be in uninitialized data segment.
No, sir. If I initialized with 0, so then
Yeah.
also it will be in the initialized data segment itself.
Yeah, obviously.
Oh, okay. So because like I was studying in the Geeks for Geeks, there it's written that if it's initialized to 0, then also it's considered into BSS.
Then I have to check it. But as per my understanding, I know that this is allocated in this way. I will check it then.
Okay, sir.
Okay. Okay. Then anything else?
আচ্ছা
Any other?
স্যার, স্যার বলছি স্ট্যাকে কি আমরা যেভাবে ভ্যারিয়েবলগুলো পরপর অ্যালোকেট করি লোকাল ভ্যারিয়েবলসগুলো, ওইভাবেই পুশ হয় না স্ট্যাকে অ্যালোকেট হওয়ার সময় ওখানে আবার কিছু চেঞ্জ হয় মানে অর্ডারটা?
না, স্ট্যাকে যেভাবে অ্যালোকেট করি বলতে
মানে সাপোজ আমি ফার্স্টে একটা ইন্টিজার নিলাম, দেন ক্যারেক্টার, দেন শর্ট, আপনি যেমন আগের দিন স্ট্রাকচারে করছিলেন। এখন যদি আমি ওটা তিনটা আলাদা ভ্যারিয়েবল নিই, তাহলে যে অর্ডারে আমি ভ্যারিয়েবলগুলো নেবো, ফার্স্টে ইন্ট, তারপর ক্যারেক্টার, তারপর শর্ট, তাহলে স্ট্যাকে ফার্স্টে ইন্ট পুশ হবে, তারপর ক্যারেক্টার, তারপরে শর্ট, না ওইখানেও আবার মেমোরি ম্যানেজ হয় কোনোভাবে?
না, the thing will not be allocated in that way. the variables you have declared within a function.
Yes, sir.
Okay, so in a function, if you have declared two variables, then the current state of the function will be treated as one element in stack. Is it clear? Current
Yes,
state
sir.
of the function, the whole thing will be treated as a single element in stack.
That will be a stack frame.
Hmm.
হ্যাঁ, এবার স্ট্যাক ফ্রেমের ভেতরে যখন ভ্যারিয়েবল গুলো থাকবে, লোকাল ভ্যারিয়েবল গুলো, আমি ওইটা বলছি।
The in that case, I'm not sure about it because
হ্যাঁ, কারণ স্যার একটা মানে
স্যার
ডাউট
হ্যাঁ
হচ্ছিল। হ্যাঁ, পূর্ণদীপ শেয়ার কর বা দেখো।
হ্যাঁ মানে স্যার একটা জিনিস করছিলাম তো ওখানে অ্যালোকেশনটা যেন মেমোরি ম্যানেজমেন্ট করে যেন হচ্ছে দেখলাম। মানে আগের দিন যেটা বললেন স্ট্রাকচারে যেরকম হচ্ছিল যে যখন আমরা একটা ক্যারেক্টারের পর একটা শর্টকে অ্যালোকেট করতে যাচ্ছি তখন সেই মাঝে একটা গ্যাপ হচ্ছিল।
hmm.
তো মানে মনে হয় ওই রকমই কিছু একটা ব্যাপার হচ্ছে, মানে একবার দেখবেন।
হ্যাঁ, obviously.
আচ্ছা হ্যাঁ স্যার, এই দেখুন মানে ফার্স্টে যখন এটা করছিলাম
Hmm.
তো
Hmm.
হ্যাঁ তো এটা যেটা হচ্ছিল এটা মানে 4 বাইট নিচ্ছিল, কারণ লাস্টে নাল ক্যারেক্টার সমেত নিচ্ছিল।
হ্যাঁ,
তো এটা যখন হচ্ছিল মানে পরপরই অ্যালোকেট হচ্ছিল, ফার্স্টে এটা এলো, তারপরে এটা এলো, তারপরে এটা এলো। কিন্তু যখন সেটা 4 কে এক্সিট করে যাচ্ছে তখন ওটা একদম লাস্টে গিয়ে অ্যালোকেট করছে, মানে আগে এইগুলোকে অ্যালোকেট করছে তারপরে লাস্টে গিয়ে এটাকে অ্যালোকেট করছে।
দেখো, this ordering can vary. It completely depends on the operating system
আচ্ছা
and it is dependent on many other factors, this memory allocation.
আচ্ছা স্যার, মানে ওটাই ডাউট হচ্ছিল। ফার্স্টে আমরা ভেবেছিলাম যে ওটা স্ট্যাকে মানে ডেটাগুলো অ্যালোকেট হচ্ছে বলে যেটা ফার্স্টে করছি সেটা একদম লাস্টে গিয়ে অ্যালোকেট হচ্ছে এরকম ভাবছিলাম,
No,
কিন্তু
no, no.
তারপরে দেখলাম যে না,
No.
সেরকম নয়
All
ব্যাপার।
the items, whatever you have, all the items are being loaded as a single element.
আচ্ছা
It will be a block. Okay, so the state of a function will be treated as a block or it will be treated as a single element in stack.
So, sir, that stack frame won't be having any segregation.
So stack frame means the one item of the stack. You're talking about it.
Yes, sir.
Yeah, there will be segregation, obviously, for because within that memory location, whatever variables you have used in your program, those variables will be allocated. So there will be obviously that logical segregation.
স্যার আর একটা ডাউট ছিল, মানে স্ট্রাকচারে যখন এটা অ্যালোকেট হচ্ছিল, মেমোরি অ্যালোকেট হচ্ছিল, সেখানেও একটা ডাউট ছিল।
Hmm.
স্যার এই যে জিনিসটা, এটা কি করে মানে ফার্স্টে ক্যারেক্টারকে আমি যখন এ করছি, অ্যালোকেট করছি তার জন্য, আর তারপরে শর্ট হচ্ছে, তো তখন ক্যারেক্টার একটা নিল, তারপরে মাঝে একটা গ্যাপ, দেন শর্টের জন্য দুটো। কিন্তু তারপরে আবার যখন একটা ক্যারেক্টার হবে সেটা আর একটা আলাদা ব্লকে অ্যালোকেট হবে।
মানে 8 হওয়ার কথা,
হ্যাঁ, কিন্তু 6
instead
আসতে
of
গেল।
8 why it's 6.
হ্যাঁ।
Nowadays in different operating system this value may change.
আচ্ছা।
In
এটাই।
some operating system even it happens that if you have char then short and char, then it will take only 4 byte.
cat,
So for optimization purpose some operating system manages it in different way.
আচ্ছা। ওকে স্যার, এটাই মানে দেখানোর ছিল।
Okay, any other doubt? আচ্ছা,
No, sir.
okay. Just give me 2 minutes. Okay.
Sure, sir. भार्गव,
बोल।
अरे ये बता, तेरा apt और apt-get में अंतर क्या है? जैसे अपन लिखते हैं ना sudo apt-get upgrade।
मेरे को भी पता नहीं भाई, मैं दोनों यूज करता हूँ।
अरे वही, मतलब दोनों में अंतर क्या होता है मेरे को समझ नहीं आता यार।
शायद नहीं है, थोड़ा सा कुछ था, याद नहीं है, कभी सर्च किया था, लेकिन दोनों ही चलता है तो दोनों ही यूज करता हूँ।
पूर्णा, तेरे को मालूम है क्या?
नहीं भाई।
Am I audible?
Yes, sir. What is
Yes,
the
sir.
difference between apt and apt-get?
APT and APT get.
Yes, sir.
Uh, I have to check it because mostly I do not use this command in Linux environment. I use some other command. So you are using apt-get for downloading the package.
Yes, sir. For package or upgradation.
Yeah. So I've not used it for very long time. I will check it. Okay, because mostly I'm using RHEL platform. In RHEL, I'm using YUM,
Yes, sir.
Yellow Dog Package Manager. So using that package manager, mostly I'm working. I have to check. Okay. Is there any doubt in APT and APT get?
No, sir. Once I was running some command and it didn't work in APT, but it worked in APT-get, and the other way around also. So I couldn't understand what was the difference. Like
I'll check.
whenever we do apt-get update one, so the list, whatever the list comes on the left hand side, there are a few different types of like अलग अलग segment में हो जाता है. जैसे there are few get is there, few hit is there, so it divides.
Okay. Mm, I want to share with you something, but I forgot where I have kept that file. This is not it. Yeah. Okay. I think you are familiar with this hierarchy of memory management. So this is the scenario that when we are trying to access some data, because the processing will be actually done in CPU. So ultimately the data needs to be loaded in register, then this after loading it, then the operation can be performed. So if we perform this operation when the data is available in register, have you heard of different types of register?
Yes, sir.
Yes, sir.
Yes, sir.
What are the types? Can you
Like,
remember? Yeah.
types mane example.
Examples. Just what are
EAX,
the
EDX, is ESI.
okay? In which architecture?
32-bit.
In 32-bit architecture. Okay. Have you heard of accumulator?
Yes, sir. That EAX is accumulator.
Yeah. So and stack pointer, program counter.
ESP, PCF.
Yeah. So
Yes, sir. RMA.
so if we think of 8085 architecture, okay, 8085 microprocessor, which is the very basic microprocessor, which is 8-bit architecture. Then we have 8086. So 8086 is 16-bit architecture. So nowadays we are using 32-bit architecture and mostly 64-bit architecture. So when we are working with this architecture, then actually in processor, how the things are managed. So for every processor, there's a instruction set. Okay, so if we consider i3, i5 or AMD processor, different AMD processors, different generations of AMD processors or Intel processors, then these instruction sets are different. So when you are writing a program, this program is ultimately converted to some machine level instructions. So a set of instruction is there. Okay, so based on your logic, these instructions are converted. So you are writing the program in high level programming language like C, but actually when it is running in your system, then it will be converted to machine level instructions. And these machine level instructions are different on different system. Why C is platform dependent? Why do you say that C is platform dependent? Hello?
Because the compiler can create different assembly level languages for different whenever we use platforms.
So if we compile it on Windows platform, which is 64-bit, the program may not run on 32-bit architecture, even
Yes,
in
sir.
Windows platform, because during compilation, the compiler is generating the assembly level code, and from that assembly level code, finally machine level code is being generated. Okay, which is the object file, an optimized object file. So optimization is being performed. So you will learn compiler optimization later. So when you will learn compiler, it's a paper. in computer science, which is very important paper. It's completely dependent. If you have clear conception about formal language and automata theory, then you can understand compilation technique. So you will understand compiler, that paper. So actually the processing is being done in CPU. Now here, this is basically a paper where they have shown that how much time is required for different operations. So if the data is stored in register, then only few cycles are required. So how many cycles are required, that is dependent on the instruction. Like if I want to add two numbers, okay, and these two numbers, among this one number is stored in a register, one is stored in accumulator, it's also a register, and another one is stored in another register instead of stack pointer and program counter. Okay, so if we have say one data in register accumulator A and another data in register R1, then when this operation will be performed, how many CPU cycles are required, it's predefined based on the instruction set of that system. Okay, so generally only few CPU cycles are required for performing this operation. Here they have just shown that it's 1 to 2, but it's not actually 1 to 2. It may vary based on the instruction set. Okay, now if the data is stored in L1 cache, then CPU cycles will be more, because from this L1 cache you have to load this data in register, then the operation will be performed. So for loading this data in from L1 cache to register, it will take some time. If the data is not available in L1 cache, you have to load it from L2 cache, it will take more time. If it is stored in main memory, obviously it will take much more time. Okay, then if it is stored in hard disk, then in the same hierarchy you have to load it first in main memory, then in cache, then in L1 cache, and finally it is being stored in register, then the operation will be performed. So more CPU cycles are required. Okay, so in this paper they have shown that how much CPU cycles are required for performing these operations. Okay, now the thing is, okay, if we compare it, just for giving you a little bit idea, okay, so generally in this way, have you seen this type of diagram earlier?
No.
No, sir.
So if we represent CPU clock, okay, so say my system as one single core processor and its clock speed is 2.2 gigahertz. So in 1 second it will be 2.2 CPU clocks. So if I represent this clock in this way, so this is the clock representation. Now for every operation, how much time is required, that's already defined based on the system or based on the CPU which you are using. Okay, so if an operation requires 4 cycles, so that means starting from here it will require up to these CPU cycles. So if we want to calculate the actual time consumption of a program, that how much time it will take if it is running on a system which is dedicated to run this process only, it is not being shared by others. Okay, so if we run this program, then for performing any operation, like if it's an add operation or if it's just a multiplication operation, So multiplication can be defined in different way. You know that it can be addition. So if I want to multiply m and n, we can add m n times or n m times. Alternatively, we can perform some bit shift operation and we can calculate it in smaller time. So it is completely dependent on the OS implementation. Okay, now so how much time is required, that can be calculated by a program. Now how do you run if you have only 2 core or dual core processor in your system? How much dual core processor in your system? So it means that you have only 2 cores. Okay, so if you have only 2 cores in your machine, can you run more than 2 processes?
No, sir.
No, sir.
Are you sure?
But sir, in case of like I have 4 quad core, then there are several processes running in background. It could be done.
Yeah, it could be done, obviously. Then how it is working?
Sir, I think there is something called thread,
Okay, it's
multiple
really
thread.
very concept. Yeah, you can discuss. Yeah, Purnodeep.
হ্যাঁ স্যার, বাট আমার ঠিক ক্লিয়ার নেই অতটাও, মানে জিনিসটা ঠিক অতটা ক্লিয়ার না।
একটা করে মাল্টিপল
মানে
থ্রেড
একটা,
চলতে
হ্যাঁ মানে একটা থ্রেডে সেই প্রসেসগুলো হয়তো চালু হয়।
Okay, in
Sir,
your
runnable callable is then সেগুলো কি রানেবল কলেবল এরকম কোনো সিস্টেমে রান করে, মানে যেটা যখন রান করবে মানে যখন দরকার হবে তখন রানেবল স্টেটে যাবে, যখন দরকার হবে না তখন কলেবলে যাবে।
ওরে বাবা, তোমরা তো এখন প্রচুর কনসেপ্ট দিচ্ছ। হ্যাঁ, অবভিয়াসলি আমি অতটা মানে শুরুতে এইভাবে যেতে চাইছি না। I want to discuss from basic understanding. The rest of the thing you can learn, obviously. There is a concept of time sharing. This is the main objective of operating system. Okay, so if we run multiple, if we have quad core, okay, on my system say it's a quad core processor. In every core we have 2 thread. Okay, so maximum 8 threads are there. If it's a quad core processor, in every core we have 2 threads, so 8 threads are there in my system. So parallelly 8 tasks can be executed. We can't execute more than 8 tasks in parallel. But in your system multiple processes are running. Sometimes 50 or 60 processes are running simultaneously. How it's possible? What do you think? This is the concept of time sharing. So operating system, the prime objective of operating system is resource allocation. One processor will never be allocated for a process dedicatedly. In those cases we have different types of hardware. In some scenarios, if we need a dedicated processor, then dedicated processor is a different hardware architecture which is used for performance improvement. So you are also using it sometimes. Okay, so dedicated hardware is required. But in our system, how multiple processes are running? The thing is, if you say that for every core we have mentioned that it has 2.2 gigahertz. I'm simplifying the problem. I have 4 core. Every core we have 1 thread. Okay, so in quad core system we have only 4 threads. Now 4 processes can be executed. When you are listening music, So you have played one music player. Okay. So if you have played a music player, whether it will require 2.2 gigahertz in every second?
No, sir.
No, sir.
Obviously no. So it will require only few resources. So probably if I say that this music player requires 0.2 gigahertz in every second to play this music. So if it requires only 0.2 gigahertz in every second, so rest of the CPU cycles, that means out of 2.2, 2 gigahertz is idle, that can
Yes,
be
sir.
utilized for other processes. If I say that tomorrow I will go to college, so say when I will go to college tomorrow, so I'm scheduling a meeting with Oyon. Okay. So if I schedule a meeting with Oyon, so Oyon has some doubt. He has informed me that he has some doubt. So I will sit with Oyon. So shall I say that other members of this group should not come tomorrow because I have a meeting with Oyon? Oyon has obviously some doubt. So for solving that, I don't need the whole day. So here I am the resource. Okay. So if I become a resource and Oyon is asking for a service, Oyon doesn't require 8 hours on the same day. So if Oyon requires 20 minutes, or if Oyon requires say 2 hours, okay, so rest of the time, rest of the 6 hours I can utilize with others. I can arrange a meeting with others. Okay, so say Oyon is requesting for solving a problem, so I need to sit with him for 20 minutes. After that, for the next job or next doubt clearing session, I will arrange it after 1 hour. So in the meanwhile, I can sit with Vishwajit, I can sit with in some other time I can sit with Argho. Okay, so we have to utilize resources maximally. Okay, so here the concept of time sharing is coming. So the main purpose of operating system, whether it's a Linux, whether it's Windows, any Android device, even if it's a basic mobile phone where you are running J2ME, everywhere the main purpose of operating system is resource sharing. So it will work on time sharing manner. Think of a scenario. You may feel that it's, if we dedicate a resource for a job, then what happens? Like if I say that there is a path from Chingrighatta to Rajarhat, there is a road. Okay, now on that road, if I dedicate this road for car 1, what will happen? Car 1, if it is moving from Chingrighatta to Rajarhat, then when this car will start its journey from Chingrighatta until it reaches or reaches this Rajarhat or your college, then other car will not enter in the same road. Is it a good way for resource allocation?
No,
Obviously
sir.
not. So what we do, we allocate in time sharing manner. So once a car is being allocated on this road, so when this car is moving, then next car will enter on the same road. So simultaneously multiple car will move on the same road, but at the same time, at the same instance, they will not be placed in same position. Then there will be a collision. So operating system is performing this task, that when multiple jobs are requesting for resource, in your operating system, if you are using Linux or Windows, when multiple jobs are to be executed simultaneously, but we can't execute multiple jobs, or if we have only 4 core, then more than 4 jobs cannot be executed on that processor simultaneously. So what we will do, we'll do the scheduling. Okay, so how the resources will be allocated in that case? So for one job some time slots or some clocks will be allocated, then for next job some clocks will be allocated, for next job some clocks will be allocated. In that way, in time sharing manner, the jobs will be allocated. So when you are running music player, you are editing on some text, you are multiplying n number of matrices in the background. At the same time, when you are downloading some file, so if you are running multiple jobs, then the time sharing manner, the resources are being allocated. And how these resources will be allocated, that is the main task of the operating system. Okay, now you may think that if my system, if it is not time sharing and you are listening music, what will happen? Your operating system, the objective of the operating system is it will try to utilize maximum resource. So you are sitting idle, you are not running any other program in your system, and you are listening music. So if it's a music of 5 minutes, for optimization purpose, it is being played in 30 seconds. Will you listen this music? If a 5 minutes music is being played in 30 seconds, you will never listen it. Okay, so for what kind of application, at which interval the resources are to be allocated, it will be managed. So this is the purpose of scheduling. That's why in operating system, different types of scheduling algorithms are working. Okay, now coming to C program. If we come back to C program, when you are writing C program, till now whatever programs you have written, those programs are basically single threaded program. You have not written multiple thread. Okay, so if you run this program in your machine, even if you are using quad core or hexa core or octa core, but it is actually running in single core. So when you are running a C program, but your machine has 4 core processor, but you are not able to utilize this resource, you are not getting benefit of multiple core. If you want to get this benefit of multiple core, then you have to write program in different way. You have not implemented it till now, but you have to write this program in different way. Okay, so in simple thing, let us try to understand that what is parallel processing. Like in case of microprocessor, or in case of processor which you are using in your laptop or desktop, in this processor we have multiple thread. Multiple thread means in hardware we have multiple thread. So in a processor, so in a core, if we have 2 thread, so 2 jobs can be executed parallel. Okay, so you have to write program in that way, so that we can, for the same program, we can run parallelly in 2 threads. Then coding will be something different. Now in upper level, we also use the term thread. So in C program, we can write multiple thread. Okay, so if we have some task to be executed in parallel, then we can write C program using multiple thread. Okay, so we'll discuss the things later, but we can run the C programs in multiple thread, and how these resources will be allocated, we will discuss it later on, not in immediate classes. I'm just giving you some hints so that you can explore. Okay, you should not wait for next week for 1.5 hour discussion. You should try to explore it so that we can discuss over here. Okay, so whatever I know, I will try to discuss and share these things with you, and at the same time I will expect that I will learn many things from you. Okay, so
Sir, can I share my screen?
yeah, obviously.
Sir, I have a small doubt. Like, if we do multi-threading, then will it create multiple processes?
Multiple processes.
Yes, for the single program.
Now process and thread, the things are little bit different. Obviously there is a huge correlation. A thread is also known as process, but it's lightweight process.
Okay,
Yeah,
sir.
Ashutosh.
Sir, my doubt was why in the thread section it is showing more than 2000, whereas like in one core there is only 2 threads.
Just expand it. Yeah, these threads are user threads and system threads. It's not hardware thread. That's why I have mentioned it, that in hardware thread, how many threads are available in your system, that is based on the hardware configuration. Okay, so hardware configuration means when you are purchasing a laptop, then you will say that I need quad core having 8 threads. So in every core there are 2 threads. So these threads are hardware threads, actually where the instructions will be executed. But here whatever thing you are seeing, so this is processes. So 218 is the number of processes which are running in foreground as well as in background. It can be user thread, it can be daemon thread. Many of them are daemon thread which are running in the background. Okay, now some of these processes consists of multiple threads. These are threads in respect to the programs. So these threads are basically the program threads. So we cannot run this number of threads simultaneously. So that's why time sharing is there. This is the reason of time sharing. So this 2400 threads are running in your system, but they are actually getting access to the resources in your system, and when which thread is being executed in that CPU, that will be managed by the operating system. So in your system probably you have 8 threads in 8 CPU. Am I right?
Yes, sir. Like I have total 8 logical processors.
So you have 8 logical processors. So at a time 8 instructions can be executed. But when we are running media player, when we are editing some text, when you are running some program in the background, then they doesn't require 100% CPU cycles in every second. So they require some of the CPU cycles. Okay, so in different scheduling approach, when these threads will request for resources, then for every thread in time sharing manner, the CPU is being allocated. So these threads are program threads. These are not hardware threads. Is it clear?
Yes, sir.
So when we will write some C program, if we create multiple thread, at the same time I can create 500 thread. in a program. Okay, so within that process, when I'll run this program, then when it becomes a process, within that process, if 500 threads are running, what will happen? So whether 500 threads will be executed simultaneously in system? No. 500 threads will not executed simultaneously in the 8 CPU. So resource management is there. So OS will decide that which thread should get access to which thread should be allocated to which CPU at this moment. Then in next few nanosecond, another thread will be allocated to that same CPU. For next few nanosecond, another thread will be allocated to the same CPU. Okay, in this way, it will be managed.
Okay, sir.
Okay, we need to discuss the problems. So, what shall I do?
You can continue, sir, if others have no issue.
Yes, sir, no issue.
Yes, sir, continue.
Okay, then can you share your screen, anyone, and show me the problem statement. I have not prepared the question paper yet for your tomorrow's exam.
আচ্ছা স্যার, বলছিলাম একটা করে কি মানে দুটোর বেশি থ্রেড থাকতে পারে না? মানে ম্যাক্স টু ম্যাক্স কি দুটোই, না তার কমও থাকতে পারে?
না, তুমি বলছো হার্ডওয়্যারে?
হ্যাঁ, হার্ডওয়্যারে।
এটার কোনো লিমিটেশন ওইভাবে নেই। মানে
মানে
আমাদের
কারণ
ডিফারেন্ট টাইপের হার্ডওয়্যার আছে, যেখানে
হুম,
একটা প্রসেসরের ভেতরে 8টা কোরও আছে।
আচ্ছা। না না
মানে
স্যার,
তুমি,
মানে
হ্যাঁ বলো।
কোর বলতে বলছি যে ওই মানে এক একটা কোর, যেমন আমার কোয়াড কোর হলে তার ভেতরে আমার দুটো দুটো করে যদি থ্রেড থাকে তাহলে 8টা থ্রেড হচ্ছে।
হ্যাঁ,
তো হ্যাঁ, মানে সেটাই বলছিলাম যে ওই থ্রেডটা কি দুটোর বেশি থাকতে পারে না?
হ্যাঁ পারে।
আচ্ছা
সার্ভারে ওর থেকে বেশি, অনেক বেশি থ্রেড থাকে।
আচ্ছা, মানে আমি যেগুলো দেখেছি সেগুলো সবেরই দুটো দুটো আছে, তো আমি সেজন্য ভেবেছিলাম যে দুটোর বেশি হয়তো থাকতে পারে না।
না না, একটা র্যাক সার্ভারের ভেতরে মানে আহ, আমি ধরো এই মানডে গেছিলাম, মানডে ইউনিভার্সিটি গেছিলাম, মানে নতুন একটা র্যাক সার্ভার বসানো হচ্ছে।
হুম
মানে নতুন র্যাক সার্ভারটা জাস্ট তোমাদের একটা আইডিয়া দিচ্ছি। মানে ওখানে একটা র্যাক সার্ভারে তোমার কিছু মানে 4টে র্যাক বসানো হয়েছে। মানে কিছু টাওয়ার সার্ভার আছে, কিছু র্যাক সার্ভার আছে। এই একটা র্যাক সার্ভারের ভেতরে তোমার মানে র্যাক সার্ভারগুলোর দাম পড়েছে, তোমাদের বলি, সেটা হচ্ছে ওই 4টে র্যাক সার্ভারের টোটাল কস্ট পড়েছে 2,32,00,000। এবার ওই র্যাক সার্ভারটাতে মানে ক্লাউডের সেট আপ আছে। এবার আমি সেদিন গেছিলাম, আমাকে অ্যাক্সেস করতে হয়েছিল, কারণ ওই অ্যাডমিন কনসোল মানে অ্যাক্সেসটা আমার কাছে আছে আর আমার গাইডের কাছে আছে, বাকি কারোর কাছে অ্যাডমিন অ্যাক্সেস নেই। তো ওখানে গিয়ে এবার হচ্ছে ওই সার্ভারে যে একটা র্যাক বসানো হলো, সেই র্যাকের নাম্বার অফ প্রসেসর হচ্ছে মানে একটা টোটাল ওই র্যাক সার্ভার মানে ছবি আছে আমার কাছে, আমি নেট থেকেও দেখা দেবে। আচ্ছা আশুতোষ, ক্যান ইউ ওপেন গুগল
Yes, sir.
in another tab? Right, rack server, search for rack server image, RSCK. Yeah, you can go to images. Okay, is there any, just little bit scroll down, scroll down. Okay, just open this image in the middle of the bottom. The person is removing a rack. Open this image. Yeah. So this is a single rack which is in his hand. Okay. So this is a single rack. Now this rack contains 512 number of CPU. Each and every CPU has 8 thread. It contains probably 32 TB of hard disk storage and 256 GB of RAM. This is the hardware configuration of similar type of rack which is installed there. So in that rack server we have only 4 rack. Okay, so this is the configuration of a single rack. What is the advantage of using this type of rack server? The things are getting more complex. The advantage is how these things are managed. I will not discuss right now. There are some architecture which are followed and which are configured. Generally, you do not. Okay, you have installed Linux environment in your system. All of you, I think.
Yes, sir.
Yes, sir.
Have you configured RAID architecture?
Yes, sir, I have done. I have switched from RAID, that RST1 to AHCI.
Okay. Which RAID version, which RAID architecture you are using?
That was RST, sir. That RAID version, I don't clearly remember.
You are saying RST.
Yeah, that was rapid storage technology, and it was using some RAID technology, sir. So to install Linux, it was not working, so I had to switch it to AHCI SATA.
Okay. There are some difference. Okay. Okay. Fine. Here, I want to mention that. Forget about the things. The advantage is you have some data in server. Okay. Some processing is going on. Now, even if at runtime, without shutting down the server or without shutting down the rack, you can remove a hard disk. So multiple hard disks are installed. So you can remove one hard disk, you can add a new hard disk without losing any data. This is the advantage. So servers are configured in that way. Even if some processors are not working, without shutting down the system, you can replace the processors. Okay, so this is the thing. So I think you can understand that.
আচ্ছা স্যার,
হুম,
এখানে মানে কোনো একটা অপারেটিং সিস্টেম তো থাকে,
হ্যাঁ থাকে।
মানে ওটাই কি পুরো এই যে হিউজ অ্যামাউন্ট অফ যেটা মানে আর কি এত র্যাম এত স্টোরেজ, মানে এটা কি ওই একটাই প্রসেসর, সরি একটাই মানে অপারেটিং সিস্টেম কি কন্ট্রোল করে, না আলাদা আলাদা কিছু থাকে?
Now, generally in every rack we install different operating system.
আচ্ছা,
Every rack will be considered as a single system. It will be considered as a server. They will be connected to TOR switch, top of rack switch. So using this top of rack switch, they are connected with others. So it's a network switch having 10 Gbps connectivity. Now using that connection, they are connected. মানে তোমাদের একটা হচ্ছে খুব বেসিক আন্ডারস্ট্যান্ডিং এর জায়গায়, মানে কোডে যাওয়ার আগে আমাদের একটা বেসিক একটা ডিসকাশন দরকার, মানে হাউ সিস্টেমস আর ওয়ার্কিং। মানে তোমরা একটু নিচের, মানে এই যে ডিভাইস ম্যানেজার ওপেন করেছো, try to understand different components of this device manager. The things are very important.
Sir, I remember here itself somewhere I've seen RAID.
Yeah. RAID is an architecture by which different or multiple copies of a data is distributed over multiple storage media. And in different RAID architecture, we have different types of policy, like based on that, if it's RAID 5, then how many copies will be maintained, how many duplicate copies will be maintained, which one is active copy, which one is shadow copy. For RAID 5, this configuration is fixed. There is a single logic. So even if you remove a hard disk from the rack which is running, and some program is running in that hardware, so some data is stored, so immediately within fraction of second the control will be shifted to the shadow copies and it will be managed directly. Okay, so the things are being done in different way. So I will discuss the things with you.
Yes, sir. It was the same like RST. I've
Yeah.
searched about RST. RST was like basically that even if like you have multiple hard disks, that can be treated as a single partition. So for that RST, and there was one term called Optane. So the system was working on RST with Optane, and the Linux cannot work on that environment. So to convert, I have to convert it from RST to AHCI. This one. SATA AHCI. Then only Linux was able to install, otherwise like it was not permitting.
Yeah, rapid storage technology, it's almost 1 decade old. Nowadays it's heavily used, but RAID is very old technique which is mostly used, it was initially used in Linux environment. It's also known as matrix technology. So it's basically that I should use lots of terminologies if we want to discuss the things. So it's basically a firmware based technology. Okay, so at the very beginning it was introduced, probably it was first introduced by Intel. Okay, in most of the servers RAID 5 architecture is followed, but if we say it's RAID 0, there is no shadow copy. So there is no advantage of RAID. If you remove a hard disk, then it will be completely lost. If some data is there, that will be lost. So multiple copies are maintained, but this if we talk about RST itself is basically it's a combination. In different layer we are implementing this RST. So it's just not firmware, just not chipset, or just not software. So it's, if you implement RST, then all the modules are to be, so in every layer you have to configure it. Okay, don't need to configure it manually, but when you are configuring that your system is being configured for RST, then firmware, chipset, software, CPU, everywhere some changes will be made.
Sir, I had to change it using the registry editor.
Yeah.
So like in there we have to go and change to like the values we have to change, and then only it was possible.
So when you are changing these values, then in the background many where the things are being changed. So when you are changing it in system registry in Windows environment, then in the background many where the configurations are being changed because it is working in multiple layers. Like you have to change something in firmware, you have to change something in chipset, like this. So if you okay, we can discuss the things later on. If we say that you are using Intel processor, am I right?
Yes, sir.
Oh, okay. So in Intel processor, you are configuring it for RST rate. So in traditional RAID and in RST rate, there are some changes. You can go through it. Obviously, the thing you have pointed, that's the main reason. So if you go through the details of RST rate, then you will understand that how the things are managed. All of you are a suggestion for all of you that how the resources are managed. Try to understand that in operating system which you are using, how the things are managed, so that when you are writing a program, you can decide that what kind of program needs to be implemented for what type of problem. If we want to implement the programs for whatever you are running or writing in design analysis of algorithm for this type of programs, obviously the things are not required. These programs are running on single core. But if we have multi-core, then we have to do something different. আচ্ছা, এক কাজ করি, আজকের মতো এটাকে এন্ড করি। কলেজ থেকে বারবার কল আসছে, আমি কেটে দিচ্ছি। তাহলে একটা অন্য কোনো টাইম বসে যেতে পারে? তোমাদের তো এক্সাম চলছে না এই উইকে?
So tomorrow is the last date of exams.
Tomorrow. If we can sit for no. Friday in the evening I will not be available. Friday, Saturday and Sunday. Saturday I will try to manage it. I don't know that whether I have to go somewhere, whether internet connection will be good. I'm not sure about it. It's an interior
So
location.
tomorrow at the same time, can it be possible?
Tomorrow at the same time. No, if you can arrange it at 5, it's possible. Because I will be in
Sure,
college
sir.
at the time. But generally I am not sure about the time because when I'm going to college, some days I'm leaving college at 9, some days I'm leaving college at 7. So that leaving time is not fixed. So it depends on different tasks. So are you free tomorrow in any period or in the evening, like after 4? Are you free?
Yes, sir. No issue with me.
No, sir. We have
Yes,
a
sir.
Yes, sir.
CFO
Yes, sir.
from 4
Huh?
from 4:30. We are having a CA4 exam. It will be till 5 or 5:10. It will be okay.
Okay. I'll try to sit after 5. Someone
sir, after.
can please inform me. Just
Okay.
you can drop me a message or you can call me so that it will be helpful.
স্যার 6টা থেকে করা যায়।
হ্যাঁ,
6টা থেকে।
তো 6টা থেকে করলে আমার প্রবলেম হবে।
6টা থেকে আমিও পারবো না, আমার 6:30 থেকে মিটিং আছে, ন্যাকের মিটিং আছে 6:30 থেকে।
স্যার 4:30 থেকে ইভিএস এক্সাম আছে, দেন
তাহলে কালকে মানে এই প্রোগ্রামগুলো নিয়ে ডিসকাশন করার ছিল, ফ্রাইডে হতে পারে?
স্যার হয়ে যাবে, ফ্রাইডে তো
স্যার
ফ্রি আছি,
কখন?
ফ্রাইডে হয়ে যাবে স্যার।
এই বলা খুব কঠিন, না হলে স্যাটারডে টাইমটাকে রাখো, আমি দেখছি।
স্যাটারডে টাইমটা বাড়িয়ে দিলে হয় না? মানে আপনার তো 6:30 থেকে মিটিং আছে, যদি আমরা একটু আগে বসে যাই।
আগে বসবে
হুম।
মানে এই স্যাটারডেটা আমি
Sir, tomorrow during the free period time you take it, sir. During the college hours.
না, এক্সাম থাকলে ইটস ডিফিকাল্ট, ইউ হ্যাভ টু প্রিপেয়ার, অল অফ ইউ আর নট প্রিপেয়ার্ড ফর এক্সাম, ইউ উইল রিড ইট ইন লাস্ট মিনিট।
স্যার এক্সাম স্যার।
Okay. Leave it for tomorrow. On Friday, we'll try to arrange a time. Okay. If it's not possible, then finally we have to sit in Saturday.
Okay, sir.
Okay, sir.
Should be better. You can arrange a meeting among yourself to discuss the problems. Okay, I'm leaving. Then in group we will discuss about the time.
Okay, sir.
Okay.
ओके सर,
और वो तो रुक,
ठीक है।
देख एक चीज दिखाता मैं, ये मैं
बोल।
कोड देख रहा है ना, सो तू बोला था देख मैं ये यूज कर रखा, ठीक है, मैं बहुत पहले से यूज किया हूँ, लेकिन यहाँ तक तो ठीक है, अपना अपन एफगेट्स वगैरह कर रहे हैं, उसके बाद एक लूप है, ओके
भाई
ठीक है, अरे वो तो होगा, वो छोड़ वो मस्त डिजाइन बनाया मैंने, इधर आर्ट कर रहा हूँ।
4টে ফরের ভিতরে
हाँ,
ফরের ভিতরে ফরের ভিতরে
एग्जैक्टली n to the power 4 कॉम्प्लेक्सिटी हो रहा है, तो
अच्छा,
इसको
अच्छा,
इसको देख, रन करने से ना, देख रन हो रहा है और ऑटोमेटिक, भाई अभी रन कर गया, देख, हाँ ये देख एग्जिट हो गया अपने आप,
अच्छा
बिना बिना कुछ किए ऑटोमेटिक एग्जिट। और यही अगर मैं इसको अगर मैं कमेंट्स आउट कर दे रहा हूँ ना, ये फॉर लूप को अगर मैं खाली कमेंट आउट कर दूंगा,
अच्छा
ये देख